All right, solving the equations that involve double angle identities. In order to solve an equation, the angles have to match. So this angle is 2x, this angle is x. The angles don't match. So the first thing I have to do is make the angles both be either x or 2x. And you can't change the x into a 2x, but you can change cosine 2x into just an x. So if you look at your identities, cosine of 2x, you had three options. One of those options was I could take cosine of 2x and rewrite that as 2 cosine squared x minus 1. I'm just going to erase that little bubble over top so you can see the problem. Right? Now I still have plus cosine x and minus 1 equals 0. So now that I have that, I can distribute through my parentheses. I have all the same trig function. I have all the same angles. So now I can solve this just like I did in the first half of the chapter there. So 4 cosine squared x plus cosine x minus 3 equals 0. This does happen to factor. So I need factors of -3 that when I plug in, I'll get a positive cosine there. So if I do 3 and 1 and plus and minus, I think it does it for me. So I get 4 cosine minus 3 cosine gives me 1 cosine. So if you set each factor equal to 0 and solve for cosine x, I'll get cosine as 3/4 from that first factor, and cosine is -1 from that second factor. Well, this one is just a quadrantal angle. If you look at where is the cosine equal to -1, it happens back here when x is equal to pi. The cosine x is 3/4, that I have to work a little harder for. So cosine's positive in the first and the fourth quadrant. So this is 3, hypotenuse is 4. That other side there is going to be square root of 7, which tells me this is not a special right triangle here. So to get that angle of x, I'm going to have to put this in my calculator. So if I type cosine x into my calculator, I'll have to use inverse cosine and 3/4 and see what I come up with here. It's coming up. It's still coming up. Wait for that calculator. All right, so we can type in, make sure you're in radian mode, which we are, and it was cosine x is 3/4. So second cosine, 3 divided by 4, and I get an outcome of 0.72, round it to 3 decimal places, 0.723. So in my reference angle here, if this is 0, this is 0, this is pi over 2. This angle right here is my 0.723 that we just got from the calculator. So one angle is 0.723. The other angle, let me see if I can get rid of this here. There we go. All right, so my angle is 0.723. This angle is also 0.723. To get the angle that goes from that initial side to this hypotenuse, I could take 2 pi and subtract that 0.723 from it. And if you put that in your calculator there, you get what? 5.560. So those three values solve that equation. All right, the next equation, same idea. You're solving for all reals. That's that 2 pi n stuff that we need to deal with. This angle is 2x, the other one is x. So we need to make those have the same angle. So sine 2x is equal to 2 sine x cosine x. So now my angles match, and I have a common factor, and all these problems are always trying to factor. Let's factor out a 2 cosine x. I'm left with a 1 in this first term, and I'm left with sine x in this second term. And then you can set each factor equal to 0. So cosine x is 0, or sine x is -1. And we can draw that. Oh, we're just going to use the same quadrantal angle that I have up here. It's out of the way. this guy was at 0, 0, -1. All right, so using our quadrantal angles, the cosine is equal to 0. That's happening up top here and down bottom here. So x is pi over 2 or 3 pi over 2. And then sine x is -1. That's my y coordinate. That's happening right there at the same value of 3 pi over 2. So I don't need to write that twice. I want to solve for all real numbers. So now I need to take these answers and add 2 pi n to them. Or in this case, these are both on that same vertical line there. So I could take pi over 2 and just add n, pi n to it. And that will make this angle land here or at the bottom there if n is an integer. All right, so then let's look at a couple of the examples from the homework problems there. So this one was number 11 for sine x cosine x equals 1. And we're solving from 0 to 2 pi. Well, if it was this, 2 sine x cosine x equals 1, now I have an identity. I'm going to leave that 2 out in front. 2 sine x cosine x is sine 2x. And then I could divide by this 2 out in front here, and I'll have sine 2x is 1/2. Well, that I know how to solve. If I draw that triangle, sine's positive in the first and the second. So that's 30-degree reference angle in there. Well, my interval is set up for 0 to 2 pi for x. So 2x is going to fall between 0 and 4 pi, which means I'm going to have to go around twice to gather up these angles. So my angle in the problem is 2x. That equals 30 degrees, which is pi over 6. That's going to be 5 pi over 6. If I go around a second time, I got to add 2 pi to these answers, which is 12 pi over 6, which will give me 13 pi over 6, and 17 pi over 6. And then finally solve for x. So I'm going to divide everything by 2 or multiply by 1/2 of pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. Oops, 12. Okay, so that's number 11. And then 15, my angles don't match, so we're going to make our angles match up. Sine of 4x, that's equal to 2 sine of twice my angle. So if you want to think of this as sine of 2 times 2x would give you 4x. So it's going to be the double angle identity that would be 2 sine 2x cosine 2x. So if I condense that into sine of 2 times my angle, I would have that sine of 4x. The other side is negative 2 sine 2x. I can put everything on the left-hand side here, and then I should be able to factor this. My angles match at this point, so I can factor. Take out a 2 sine 2x, and I'm left with a cosine 2x plus 1. So I have 2 sine 2x equals 0, sine 2x is 0, and then for this one I'd have cosine 2x is negative 1. So these are going to be quadrantal angles again. Right, cosine is negative 1 back here at pi. Sine is 0. At 0 and at pi. My angle, though, is 2x, which means I have to go around twice to 4 pi. So to gather up my angles for sine 2x is 0. I have 2x is 0, pi, going around a second time, 2 pi, 3 pi, and then also 4 pi, but it's not including 4 pi, so we'll stop just short there. And then cosine 2x equals negative 1 at pi and also at 3 pi. So I already have those answers listed. And then finally solve for x. So divide everything by 2. And my answers then fall between 0 and 2 pi.